Moving on to next topic, which is scattering of light. Now students, what exactly is scattering of light? I have already written the technical definition which you will find in the books, but I will explain it to you in more simpler words. See, suppose this is a marker, this is a marker, you don't have to suppose it. Now you can see this marker when light gets reflected from it and it enters your eyes. That is very simple science. Now just start diminishing the size of this marker, okay. Suppose the marker has diminished up to this much size, still it is very large as compared to the size of light rays. So what we are trying to do, we are trying to shrink this object up to a point where the size of this object is comparable to the wavelength of light. Okay, I'll explain to you in more simpler way. Suppose there is this huge water valve, this much large water valve, from which this much portion of water is coming out in a very speedy way, bulged way, okay. Now I have kept this marker in front of this whole water log. What will happen? The only this much part of the volume of the water will be obstructed, whereas rest of the part will flow out easily, right. This is exactly what happens when you shrink the size of an object on which light wave is falling. What will happen? The size will be so small that whole light will not be reflected, rather it will be partially reflected. So some part of the light will be transmitted, whereas some part of the light will be reflected. That is called scattering. So scattering is actually the process of absorption and then re-emission of light energy. So why we are studying this scattering and what are its effects? Have you wondered why sky appears blue? Okay, if sky is blue, then why sky appears reddish, orangish type during morning and evening time? That means during dusk and dawn. Why? Okay, if there is no atmosphere, why do, for example, when astronauts go in space, why do they see that sky is black? They don't find any color of the sky as we see it from the earth. All these reasons are hidden in the fact of scattering. So first of all, I have explained you what is scattering, and I will give you a very important point, that is scattering is inversely proportional to wavelength raised to power 4. So whatever light which is going to get scattered from the obstructed particles or from the dust particles, see, the most important point, when I was trying to shrink this object to the size of the wavelength of light, that time you should have noted that scattering depends on the size of the obstructed particles. So scattering can be done only from those particles which are very small in size and their size is comparable to the wavelength of light. So not all objects and particles can scatter the light. For example, these markers my hand, they cannot scatter light, they can only reflect light because their size is very large as compared to wavelength of light. But small particles can partially reflect light or they can scatter light, alright. Now scattering is also inversely proportional to wavelength raised to power 4. That means light wave which has highest wavelength will be scattered least, whereas the light wave which is having the least wavelength will be scattered the most. And using this thing, I will be explaining 4 phenomena, such as, let's start from number 1, blue color of the sky. Now sky appears blue, right? Why so? Because suppose this is earth. Earth is basically not spherical, it is kind of oval, it's also ellipsoid, right? So this would be the atmosphere of earth, even oval. So when sunlight enters the surface, so this atmosphere causes scattering of light. All the dust particles, all the gas particles present in our atmosphere causes the scattering of light. So out of this whole pattern, which color will be scattered most? Violet, indigo, bluish portion, because they have the least wavelength. So due to the scattering of last part, which is the violet, indigo, blue part, scattering is most, and that is why bluish, reddish, bluish or this indigo, bluish, violet type color is prominent in the sky, and that is why sky appears blue. So I will repeat it, blue color of sky is due to the fact that when sunlight enters Earth's atmosphere, the bluish portion of the light is scattered the most because of this fact, and sky appears blue because it is the only color which is reaching our eye. But same phenomena changes when we are talking about morning and evening time. So reddish color of sky during morning or evening. Why so? Now reddish color of skies during morning and evening is because during morning and evening time sun is at these positions. So the sunlight has to travel a lot of distance in the Earth's atmosphere. Now what will happen due to large distance? The portion which is scattered the most, that is this much portion which is scattered most, will not even reach the surface of Earth. Only that portion of light which is being scattered least, which is this portion, orangish yellow red, which is being scattered least because of this fact, is only portion of light which is actually able to penetrate through the atmospheric layer and reach the Earth's surface, and hence sky appears reddish color. So the fact is clear why sky appears red during morning and evening, because the portion of light which is scattered most do not even reach the surface of Earth, whereas only that portion of the light or that portion of vibgyor pattern reaches the Earth's surface which is scattered least, and hence it can penetrate the thick layer of atmosphere due to longer distance traveled by the sunlight. Now next point would be, why do you think clouds appears white? Now we have just seen that the scattering of light causes the variation in colors of sky, but what makes them, or what is the phenomena behind white color of clouds? See, what are clouds? Clouds are concentrates of dust particles, gas vapors or water vapors, impurities, ice crystals which are called ice flakes, etc. So all this recombination condensed part is called, basically lump of the condensed part is called cloud. Now some of these crystals like dust particles, not exactly dust particle, like water vapor or ice crystals, they are quite bigger in size, so they cannot scatter light at all. But some particles are very small, they can scatter light, but since they are distributed in condensed form over a small area, so whatever light is which is being falling into the cloud, they are all scattered, like all the light rays are scattered in equal proportions. So they scatter and then they recombine. So when white light passes through clouds, either light do not scatter or they scatter in equal proportion. That is why the clouds appear white. That was the third point. Lastly, the fourth point would be the black color of sky in absence of atmosphere. See, when astronauts go out in space, they see that the overall thing is black, right? So why so? Because they cannot see any color, because there is no scattering taking place in the absence of any atmospheric layer, and that is what will happen if the Earth's envelope, that is this atmospheric envelope, just vanishes. The sky will appear completely pitch black because there is no scattering taking place. Now some students often confuse this scattering with twinkling of stars. See, twinkling of stars is a phenomena which is not associated with scattering of light. That is because twinkling of stars is basically not a fact. Stars do not twinkle, but the light which is coming from such a far distance, like from a star, enters Earth, and Earth has different layers. So different refractions takes place at different layers of atmosphere, and hence light gets in our eye in vibrating mode. Basically the light which was coming straight, it is now vibrating because of multiple refractions from multiple layers. So that is why stars appears to be twinkle. So only that source of light which is at a very far distance can twinkle. So nearer points cannot actually, we cannot find them twinkling, right? So twinkling is a phenomena which is not associated with scattering of light. So this was all about scattering of light.